Welcome back, Algebra 2. Again, today is going to be the second part of section 13-4, dealing with the compound interest. Prior to, in the last video, or the part 1, we used the compound interest formula. All right? Now, what we're going to do next is, the next type we're going to cross is compounded continuously. Now you got to be very careful when it comes to the homework problems. You got to look at the directions. You're going to either see compound interest formula based upon quarterly or annually. This one deals with compound continuously. And the formula we're going to use for that, if we were to look at all that mumbo jumbo, leaves us with this formula right here. So this formula, once again, is the value of our investment at a certain time equals your principal. That's how much money you are investing. E, once again, E is that button in your calculator. This is a base of E. Your rate, in this case, has to be a decimal. And then this is time in years. All right, so we're going to use that. So the very first thing they did here is a continuation of what we did yesterday in the last video. Again, here's our two equations. These are a little bit easier. Remember now, in order for us to graph these, we've got to have it set up in our window correctly. So I went ahead and changed it. In the last video, I showed you how to go back and make it into the factory settings. So again, I'm going to change it now. And I'll remember to fix it when I want to use it at another class. Here we go. So again, see what this looks like graphically. So you go to your y equals, clear my screen from the last time. So it'll be y equals 5,000. E, so we have to do second equal sign, raised to 0.035x, and y equals 12,000. Graph it. Let the calculator do its thinking. There's the exponential function that's being graphed on the calculator. And when it gets done doing that, it'll graph the y equals 12,000. This is the problem where we want to figure out how much time when it reaches $12,000. There it is. Second trace. We want to intersect. You'll see it's blinking at the first function. Hit enter. It's blinking at the second function. Hit enter. Down here it says, oh, we can make a guess now. There's the guess. Down below shows you what the answer is, 25.01. So based upon the problem here, it reaches a value of in about 25 years. Not bad. Again, if you're doing investing, you got to be patient, okay, just to let you know. All right, the next one is pretty much the same thing. Compounded continuously. You don't have to worry about the n. It's just a straight up formula. That's this one right here. Compounded continuously. P is your principal. So this one they indicated as 350. Your rate is a decimal. Setting it up into this formula. There's your first equation. And y equals 1800. I think you've seen enough of that. You can handle it, okay? All right, let's look at the your turn. Pause your video. Okay, try it yourself and come on back. All right, I'm certain you tried it. So a person invests $1,550 in an account that earns 4% annual interest, compounded continuously. Find when the value reaches $2,000. So first things first, you just set it up based upon the problems. Okay. So I need to go and change my numbers. Clear that, clear that. So 1550, second division gives me the E, raised to the 0.04. That's taking your percent and changing it to a decimal. X equals, the next one is 2000. Graph it. Again, it's thinking. It's still thinking. It's still thinking. There we go. We're able to see where it intersects, so now we can go second trace, intersect. It's blinking on one of the equations or one of the functions, enter. It's blinking on the second function, enter. Now we're ready to guess. And if you have done this correctly, you should have gotten 6.37 years. All right. This one is a relatively easy section, okay? It's just a matter of asking yourself which formula you're going to use, okay? All right, now quick recall. The first part of section 13.4 is your compound interest formula. That is the first video, okay? The second one we did was the formula for compounded annually. Wrong one. That is the same one. The second one we did is compounded continuously. Remember now, there are directions. You got to pay attention to the directions. The directions are going to tell you what to do. All right, now the next one we're going to finish up with is taking and doing what is called finding and comparing effective annual interest rates. Now, what this one is going to do is give you two different investments, and you're going to ask yourself which one has a better interest rate. And that formula we're going to use is this one right up here. Again, all this mumbo jumbo they're saying right here is nothing more than this formula right here. That's pretty much it. So this is your third formula in this section. This is when you want to do a comparing interest rates from two investments. All right, so I'm going to skip the page because the other pages are relatively easily. So what I did is I just went right to the your turn. And we see Jacqueline plans to make a deposit in one of the accounts shown in the table. In other words, she went to her bank, and the bank had two different things to invest in. She wants to maximize the interest that this account earns, and she needs to choose which one to account. All right, now this one just straight up calculator work, okay? So again, using that formula that I just showed a moment ago, and I just got rid of it. Oh, it's right here. It's this formula right here. R is your interest rate. N is asking you, again, this has to deal with the compound interest formula, okay? That actually comes from the derivation of this guy. N is how often are we going to compound the interest, minus 1. All right, so account X, we have 4.24%. So its rate is 0.042. And then the compounding period is annual, so we just have to leave it as 1. And it's also raised to the 1. That is account X. Then account Y has an interest rate of 4.18, but it has a compounding daily. Okay, I don't know why I have 356 right there. That's supposed to be 365. 365. My dyslexia kicked in. All right, so all we got to do now is take this formula and do our math. Do this formula here, do our math, and compare the two results. All right, so I'm going to do it for us, okay? So ready, let's clear my screen. So I'm going to do it. Here's how I would do it. 0.0424 divided by 1. That's this part of the problem. I'm going to add a 1 to it. Okay, and then I'm going to take away 1, and I think I made a mistake somewhere. Okay, 0.0424 divided by 1. I think I made a mistake somewhere. Let's think. Did I do something wrong here? 1 plus r over n is annually. Yeah, we get 0.0424. I probably did it right. It just doesn't seem right to me. I just don't want to go and start all over again. Your turn number 6. I gotta go back and look at my paper that I did earlier. Oh my goodness. Sorry guys. It's no problem. Yeah, I did it right. Okay. So again, the interest rate, yeah, I did it correctly. It just doesn't make sense to me. Is 0.0424. All right, so let's look at the rate of the Y account. So 0.0418 divided by 365. I'm going to add 1 to that, and then subtract 1 from that. They gave us a really weird thing of 10 to, it's really going to be, that's really messing me up. Oh, guess what? I forgot to do the power here, okay? It's been a long day. Okay, really, let's do this one more time. 0.0418 divided by 365 plus 1. I'm going to take that answer and raise it to the 365. And then I'm going to subtract 1 from it. Yeah, that's much better. So the interest rate for the Y account is 0.04268. And we need to compare these two. Okay? And based upon this, and based upon what they the directions tell us here, that account Y has a greater effective rate, and Jacqueline should be investing in account Y. So again, she found that this has a better interest rate, better effective rate than this one, all because of, if you look at here, this is 4 and this is a 6. Since the 6 is higher, that's going to have a better effective rate. So she should invest in account Y. All right, peeps. That is section 13-4. Again, pay attention to what the directions tell you to do, which formulas you want to use, how to set up your calculator, watch your window. I think you'll have no problem. All right, that's it. Thank you.